Our next three speakers, we're fortunate in that we have some observational studies around treatments in riparian reserves. So since the Northwest Forest Plan, we actually have some science, some things we've been able to test and see. And these guys are going to talk about that. This first speaker is going to talk about RipStream. I saw Jeremy Groom speak here at OSU last fall, I think, winter on RipStream, and I went, wow, that is really cool. I need to get that out in front of a bunch of people. So here he is in front of a bunch of people. He's currently the monitoring coordinator for the Oregon Department of Forestry, so he dabbles in research and management. So help me welcome him while I get his presentation up.
All right, so this morning I'll be telling you about a study that's taken place on some non-federal land. We call it RipStream. And this is a project that's conducted by the Oregon Department of Forestry. RipStream more or less stands for Riparian Function in Stream Temperature. And what it represents is a step in our adaptive management cycle. So the Department of Forestry for water protection, there are some rules in place, and what the department does is we conduct monitoring to see if the rules are adequate to provide the aquatic protection levels we're seeking. And if they're not, well, regardless, the findings get reported to the Board of Forestry, and if they determine that there's been some degradation in water quality with harvest occurring according to our plan, then what happens is a rule change takes place. And what's interesting right now is the Board of Forestry is actually, as a consequence of this study and some other information, in the process of rule revision. So what this RipStream project involved is this takes place in the Coast Range and on state and private forests. Its objective is to evaluate the effectiveness of forest practice rules and strategies of protecting both stream temperature and promoting riparian structure. Today I'll be speaking mostly about the stream temperature aspect, but in the future I'm going to be excited to speak more about what's happening in the riparian areas. So there's 33 sites. 18 of these are on private lands and 15 are on state forest sites. So the way we achieve our water quality goals is through buffer retention. And I mentioned the private forests versus state forests because they're managed in some different ways. On private lands, all landowners must follow the Forest Practices Act. And for that, there's a 20-foot no-cut buffer on small and medium type F streams. The F stands for fish-bearing. And a 50 or 70-foot limited entry buffer depending on stream size. And when I say limited entry, what that means is we're seeking a certain basal area around those streams of conifer trees. If the basal area is met within an area narrower than 50 or 70 feet, then you can go in and harvest the remainder. On the other side, you'll see state forest. And state forest must follow the Forest Practices Act as well. However, they have some different management objectives, including timber harvest. And so to meet these multiple objectives, they have a 25-foot no-cut buffer on small and medium type F streams, and a 100-foot limited entry buffer, and there's two types of limited entry buffers here. The first is for ecological maintenance of these sites. And so if entry does occur here, it is to, in a sense, release stands that are too dense and grow some larger trees. The second, though, is much more like private forests. From 100 feet to 170 feet, it's once again a basal area and number of tree retention in that zone. If those are met, then the other trees may be felled. So going back to that map, the idea of the map, 33 points on the map. What I want to convey is this was a large project. It started in 2002 and required a lot of effort at each of those points. We had 2 years of pre-harvest data and 5 years of post-harvest data at each site. And what that meant was landowners, private and state, needed to tell us, first they needed to say, yes, we will agree to the study and we will hold the control reach unharvested for a full 7 years, even though it has marketable timber. And they let us know where the timber harvest boundaries would be in 2 years' time. So there was a lot of cooperation there. And so this is what it would look like pre-harvest and then post-harvest. And so we had reaches designated this 1W, 2W, the W stands for water. Those are our water temperature probes. And the placement delineated the reaches themselves. So we could see what the change in temperature was over the reaches. And some other details about how the study was conducted. So we can't control with the FPA what happens on both sides of a stream because sometimes there's ownership issues or the landowner has certain management techniques. And so for state sites, 13 of the sites were one-sided harvests and two had two sides harvested. For the private sites, we had only 4 that had a single-side harvest. The rest were 2 sides harvested. As far as harvest types, state cooperated greatly. That they did is 7 sites were partial cut and 8 sites were clear cut. You couldn't ask for more cooperation in a study, but they didn't plan it that way. We just accepted their sites. The private sites, all 18 sites were clear cut. So starting in 2002, ending in 2010, as far as data collection, what did we have? We have quite a bit of stream temperature data, I think almost 2 million temperature readings. We have shade data. These streams were repeatedly walked up, and using digital hemispherical photography, we were determining what the shade levels were. Channel morphology, we have gradient, wetted, and bankful widths and depth and things like that. And riparian vegetation. We didn't dwell on these data too much for the temperature analysis, but we will more in the future for some of the other analyses we'll be running. We had, in the treatment reach and in the control reach, 2 500-foot by 170-foot plots, which were 100% cruised for timber and had vegetation plots downwood examined in them. And essentially, the data collected were there to feed programs like FVS or Organon or other stand growth simulators. So the questions I'll be examining today are, how did temperatures change immediately post-harvest? And then again, out to 5 years post-harvest. And there's 2 ways we can look at these questions. First of all, we're conducting this in order to see if we're meeting some regulatory obligations. And so we have a regulatory analysis coupled with that. But we're also interested in finding, well, what did happen to these sites and what affected stream temperatures? For the regulatory analysis, there are 2 Department of Environmental Quality water temperature standards that we're interested in. And the first is a hard and fast threshold. It's called the biologically based numeric criteria. And it asks, were stream temperatures raised above either 16 degrees Celsius or 18 degrees Celsius, depending on how those waters are used by salmonids. And so it's a hard threshold. Does timber harvest raise it above those levels? The second is effectively an anti-degradation standard called the protecting cold water criterion. It asks, were streams warmed, regardless of their temperature, by more than 0.3 degrees Celsius? Did they change? In short, the answer to the first one was no. As a population, we did not see elevations above these thresholds. And the analysis was relatively straightforward. The protecting cold water criterion, we found that yes, for private sites, but not state sites, the streams were exhibiting an increase in temperature above background levels. And the analysis was more complex, but I will spare you. For the numeric criteria, just wanted to give you a better idea of what we found. So 12 of our sites had the 18 degrees Celsius criterion and 21 had 16 degrees Celsius. And 7 out of the 33 sites, there should be 33 boxes up there, they exceeded the threshold at that 3W probe. That's just downstream of the treatment reach. So that's the probe we would have expected to see get elevated above these thresholds if there was a timber harvest signal. I color-coded them. So 3 sites are green because the control and the treatment reach both exceeded during the same year, which would potentially indicate that the stream is warmer, but not necessarily that the treatment reach was due to harvest. Yellows are somewhat more difficult to ascertain. So for one of them, a treatment probe pre-harvest exceeded, and then post-harvest exceeded. And was the post-harvest exceedance due to harvest? That wasn't totally clear. And for another one, the control probes during the pre-harvest years exceeded, and then the treatment probes downstream during the post-harvest did. So it could have been a harvest signal. And finally, we had 2 of the red sites, and that was just that 3W probe alone that exceeded those thresholds. We did some additional analysis to really dive into these data. I looked at them this way because this was how the rule language was specified. We were just looking at the warmest 7-day period in the summer. So this is what it told me. But to take a step backwards, since we had hourly data, what did we see? And it looked like 3 out of those 33 sites had a harvest signal that was pumping them above this threshold. So what we've concluded, and DEQ has concurred, is that there's no strong indication that these standards are exceeded. On to the protecting cold water criterion, and I want to spend just a little bit of time here because this is the study that has, in effect, triggered the rule revision process at ODF. And so what I want to get across here is we had a great deal of control with this study setup, and I can laud this study as much as I want because I didn't design it. And so what we have are these are 3 reaches. Well, to be fair, there's a downstream reach between 3 and 4W, and only 18 of our sites had that downstream reach. It wasn't feasible to have that reach in the other sites. But all the other sites had the upstream control and treatment reaches. So we have these 3 reaches, and we also have 3 time periods that we can examine to see where we see a harvest effect, or where we see a change in temperature, rather. And so I mentioned that we have these 3 reaches, and then for these 3 time periods, what I'm talking about here is we wanted to look at these data the way that we could minimally look at them using the regulations. That is, how many years should we be examining to determine whether or not there's a change in temperature? And we said to ourselves, well, the rules aren't explicit, therefore we think that perhaps 1 year pre-harvest, 1 year post-harvest could be used. So if just using 1 year compared to another year, what sort of results do we get? And so the way we did these comparisons within a site, we could say, was there a change between the first year and the second year pre-harvest? If there was, that represents sort of a background signal in these systems. These systems are messy. We're looking at stream temperatures across a wide area for a 0.3 degrees Celsius change. That can get difficult. So it'd be good to know what sort of a signal we see there. And then for more of a treatment effect, what would happen between a pre-harvest year and a post-harvest year? And finally, even within the post-harvest years themselves, what level of exceedance did we see? So in effect, what we're nailing down here is that you can look at all of those year pair combinations in all of those reaches, and if there was a timber harvest signal, what you would expect is that middle box to have a greater percentages of exceedances than the others. So we had 614 comparisons total, and 65 of those were exceeded the 0.3 degrees Celsius change. So just to boil down the findings, thinking back to that middle box, was it that middle box, were there more exceedances there? Yes, there were for private sites. For state sites, however, the best model that was selected said treat that treatment reach pre to post harvest in the state sites, just like any other of the control sites, and that's a best fit for the model. So for private sites, pre to post harvest is a 40.2 probability that any one of those year pairs will exceed. And I want to really make that point that it's like a pre-harvest year compared to any post-harvest year that we saw that exceedance. I'm aware that this can come across as confusing because some people say, oh, 40% of the sites exceeded the protecting cold water criterion. Actually, it's more like 60% because we're doing all of those comparisons. So we published that work in Water Resources last year. And then we wanted to ask, okay, that was convoluted, so what actually happened at these sites? And well, how much did the temperature change and why? And what we found is that for private sites, temperatures increased by, on average, a 0.7 degree increase. There's variability amongst that. If you've studied streams, they're variable beasts. Some increased by as much as 2.5 degrees Celsius, and some decreased by almost a degree Celsius. State sites, and this I found somewhat miraculous, the mean was 0.0. I've never had that before in a study. And there was around that mean about a plus 1 degree Celsius or minus 1 degree Celsius by the sites. So temperature increases as modeled. One of the main predictors that came out of that was shade, which validates many years of study on these sites and was reassuring. And it also meant that I felt more comfortable with our measurement techniques. But, so we know if shade's related to changes in temperature, but what affects shade? This is where we could pull in some of the vegetation data. Shade itself was related to riparian basal area. The more basal area you had, the more shade you had. And negatively to tree height. This was this particular variable didn't contribute as much to the explanatory powers of the model, but it was there. Basically, the shorter the trees, the more shade, which I thought was interesting. Thank you. And so this was published in Forest Ecology and Management. There was a change in shade, as you can see, for the private sites post-harvest. Those are the dark circles. A lot of sites do drop in their levels of shade, but not all. State forests, and I pulled this out for this talk because I think this is the state forests most closest of these systems that mimic what's being discussed today for federal lands. And so what related to stream temperature changes for state were treatment reach length and the control, which was positively correlated. I included the control reach change in temperature, which for the other model sets was very well supported, and this one happened not to be significant. And what was interesting was that there was a negative correlation with whether or not a site was clear-cut post-harvest. So for shade sites, as you've just seen in the previous slide, the shade hadn't changed much between years. We didn't see much change in basal area within the 170 feet or 53 meters. And we were a little puzzled by the negative temperature change with clear-cuts association. The last study I'll tell you about is preliminary findings. And we had this interesting variable for it. We were asking what happened in the 5 years post-harvest. Did the temperatures stay elevated? Did they decline? And what we did for the analysis was we had this variable that said how many years, what was the initial change at the site post-harvest? That might tell you a lot at what you would expect the temperatures to be. If you had a large increase in temperature, well then even if you saw a decline, the temperatures would be elevated compared to a site that didn't have any change. So the response was just the change in treatment temperature between that upstream and downstream probe. Predictors were the treatment reach length and control temperature change like I discussed above. And then pre to post differences, that's that variable I just described, and so it mattered. So the greater the overall, the initial change you had between the pre-harvest and the first year post-harvest, the more of those water temperatures are going to be elevated. And then the years post-harvest matters as well, but it's a negative relationship. And finally, the pre to post and years interaction was also negative. And so in modeling this, we have this is what the pre-harvest change was. So the downstream probe is a little warmer than the upstream probe before harvest. These black circles are observed, white circles are predicted, so I feel happy about that. And what it's saying for this one site is that it was modeled and did follow this trend of temperatures declining over those 5 years. Interestingly enough, shade, where you had the greatest decline in shade, they also started coming back after 5 years. We think this is probably the understory. That's what it certainly looked like to us, some of the understory coming in and shading these streams. The streams did not, in the 5 years, reach a pre-harvest condition, but they appear to be, on average, on that trajectory. So just as a summary, initial harvest response for private sites, temperature increase, and there's a shade decrease. For state sites, we didn't see a signal. And the RMA basal area and shade were relatively unchanged, and clear cuts beyond the riparian management area did not result in a temperature increase. And shade itself, overall, was related to basal area and tree height. As far as the 5-year response, similar important factors came into it, and temperature, an initial increase was followed by a decrease, and the opposite was true for shade. So next, we'll be looking at downstream temperatures and what happened in that downstream reach. And I'm also excited to be delving into some of our wood recruitment questions. Thank you.